There are about 625 million wearable devices shipping this year. Things like this and this: smartwatches, fitness trackers, health sensors, devices that collect your sleep, your heart rate, your stress levels, your movement. Right now, the AI that learns from that data mostly lives on a server. Your raw information travels there, trains a model, and that model comes back to your device. You didn't necessarily think about that when you bought the watch. Most people don't. Federated learning has been trying to solve this for close to a decade. The principle's pretty straightforward. Push the model out to the device, train it on your local data, and send back only the model's parameter updates, not your health records, not your raw readings. Your data stays on your wrist. Problem is that most wearables have never had the memory or processing power to do this at any real practical speed. However, MIT published a paper this week that directly addresses that constraint. The framework is called FTTE, or Federated Tiny Training Engine. 3 specific improvements: they reduced on-device memory requirements by 80%, cut the data each device has to transmit back by 69%, and sped up overall training convergence by 81% compared to standard federated learning approaches. They tested it in simulations of up to 500 devices, with 90% of those devices being slow or underpowered like most of our devices, which is a realistic picture of what a real-world sensor network looks like. The researchers called out healthcare and finance as the target domains. Those are the 2 categories where sending raw data to a cloud server carries the most concrete risk for patients, clients. Anyone whose sensitive information ends up in a breach that costs on average $9.77 million to remediate. So the good news is that FTTE narrows a resource gap. It doesn't close every gap in this space. However, federated learning can still be attacked. Model inversion is a real technique where a bad guy can partially reconstruct private training data from the model updates themselves, even without seeing the raw data. And the team acknowledged directly that training faster under tight memory limits means accepting some accuracy reduction. For tracking steps, fine. But for monitoring a cardiac patient at home, the threshold's a little different. And yet, this is foundational research being presented at a credible conference. The distance from a working framework to firmware on a consumer device involves a lot of things: regulatory review, hardware partner agreements, and real-world validation across patient populations. What FTTE does is bring a technique that was previously out of reach for most wearable hardware into technical range. Whether that translates to deployment depends on what device manufacturers decide to do with it. Sources are in the description, and be sure to like, follow, and subscribe for more AI and robotics news.